So let's take a look at graphing functions and their derivatives. So looking at number one, let's say we are given the graph of f of x and we're trying to graph f prime of x. How could we do that? Well, the very first thing I look for is where the slope of the graph of f of x equals 0. So we're looking for those horizontal tangents. And I see one here and here. Since derivative is the slope, and the slope is 0 at those points, then the derivative will also equal 0 at those points. So at point B, I'll put right there, and at point D. Since the slope is 0, the y value of the derivative will be 0. And next I look for the increasing and decreasing intervals. So let's say from point A to point B, the graph of f is increasing, which means the derivative has to be above the x-axis. And the slope is slowly getting closer and closer to 0, which means that the derivative will also slowly get closer to 0. So we're above the x-axis and slowly getting closer to 0. So that's what from point A to point B what will look like. Now from point B to point C, the derivative or the graph of f is decreasing and the slope is slowly getting bigger. And when the graph of f is decreasing, that means f prime will be below the x-axis. And since the slope is getting bigger, it'll also get more negative. So it's going to look something like this. And then from point C to point D, the graph is still decreasing, so f prime has to be below the x-axis. But notice how the slope is getting closer and closer to 0, which means it's decreasing. So it'll go back to 0. So I'll kind of draw like a smooth curve back to point D. And then from point D to point E, the graph is increasing once again, so the derivative will be above the x-axis. And the slope as well is increasing, so it'll get bigger and bigger. So it looks something like this. And keep in mind that these don't have to be exact, but it gives a pretty good representation of what the derivative should look like. So let's say instead now for number 2, we're given the graph of f prime, and now we're trying to graph f of x. So with a graph like this, I would probably just start off at an easy place, like when we're going from point C to point D. So in this case, the derivative is above the x-axis, so we know the graph of f is going to be increasing. And at the same time, the y values of f prime are also increasing. And since the derivative is a slope, the slope of f would also be increasing. So it'll look very similar. So maybe something like this. So now we have to look at point C. Exactly at point C. And we know that at point C, the derivative is 0. And we know that when the derivative is 0, there is going to be some kind of max or min. And since it's changing signs, so going from a negative to a positive, we know that it's going to be f is going to be decreasing and then increasing. So that means that point C is going to be a local minimum. So if I were to sort of curve it up like this and then go up all the way up to that discontinuity. And on top of that, we also know from B to C that f prime is below the x-axis, so the graph must be decreasing. And on top of that, the y values are also getting closer to 0, so the slope is also getting closer to 0 from left to right. So now we're looking at point B, and notice how point B has a discontinuity for the derivative. And we know that derivatives are discontinuous, or derivatives cannot be defined at things like corners, cusps, sharp turns, or vertical asymptotes. And this is most likely going to be a sharp turn or a corner. And you see how at point B, or to the right of point B, it has a negative derivative, which means the graph has a negative slope. And to the left of point B, has a positive derivative, which means the slope will be positive. So it's most likely going to look like a sharp turn, like so. And then finally, from point A to point B, we know the derivative is positive, so the graph is increasing. But notice how the y value is the same from point A to point B. It never changes, which means the slope is going to be constant. So it's going to look like a straight line from point A to point B for the graph of f of x. And then there's a closed dot at the end. So I just changed the lines a little bit just to show how point B to C should be a little bit more curved and point A to B should be a straight line. But regardless, this is how the graph, or this is what the graph of f of x should approximately look like.